Myself Sachin Akeli, 1V19 CV026. I am going to present a topic on piezoelectric roads under the guidance of Mrs. Lavanya, Assistant Professor, Civil Department, Sri Venkateswara College of Engineering, Bengaluru. Overview. Introduction, literature review, utilization of piezoelectric roads, methodology, applications, advantages, disadvantages, conclusion, references. Introduction. At present day, electricity has become a lifeline and its demands is growing steadily. It seems no and in different ways. It is also a pollution free. It raises a gap between demand and supply of electricity. The other hand, traffic is increasing day by day around the world. It can provide the pressure is moving vehicles in electric current. Piezoelectric has been around for a long time. The main advantage of this road is they offer sustainable and renewable energy. It is generated in large scale. Nowadays, technology has improved like existing road infrastructure, making it practical solution for many cities and regions. In piezoelectric roads, the electric stages of development, the challenges to be addressed before they can be widely implemented. The higher cost of installing the technology as well related to durability and maintenance. Piezoelectric roads become an important part of transportation. Literature review. Mr. Bhattacharya has experimented by placing piezoelectric materials tires on top of wheel rims. Author has experimented setup with piezoelectric. It is placed tires connected to full wave bridge rectifier to convert voltage output. It also serves the converting AC voltage into DC voltage. Batteries are needed in short time to charge comparatively longer duration. In 2018, the paper presentation was published by Arturo Rodriguez on various energy-like application of piezoelectric sensors, and it is made up of calibration with the help of wind power. The calculation and geometry energy has stored measured to utilize MS Yahya and Aminu Rashid has experimented with the help of piezoelectric materials for generation of energy. Experiment of consist piezoelectric material which will be placed at engine and air filter output. Output of this voltage has been stored in further use and later energy is generated. Low vehicle is not moving in vibration is less than that area. When the system generates energy after few minutes, just it is constant. The author has analyzed designs the vehicle suspension system. Zhen Zhao and Tai Wang has designed an energy harvester with the usage of piezoelectric materials. It is designed for suspension system of vehicle. Dual mass suspension system has been carried out results and its vibratory effects of driving speed on relative displacements. Energy is harvesting improve the efficiency of vehicle. Utilization of piezoelectric rods. It is designed to generate electricity from pressure and vibration. It is caused by movement of vehicle on surface. Here some of the uses of piezoelectric rods. Power generation. It is one of the most obvious use of piezoelectric rods. It generates electricity from mechanical energy to produce vehicles. By electricity, power can be used to transfix signals over street lights and others infrastructures. Energy storage. The piezoelectric rod uses to store energy and electricity is generated by the stored in batteries and other energy devices. Traffic monitoring. By analyzing the electric signals produced by piezoelectric materials, it can get information by traffic patterns with vehicle speeds and other important data. Road maintenance. Road can be used to monitor condition of road surface by analyzing electric signals. Environmental monitoring. It is also used to electrical signals produced piezoelectric monitors. It can get information about noise levels, air pollution and other environmental factors. Methodology. Piezoelectricity refers to ability of certain materials to generate an electrical charge in response to applied mechanical stress and vice versa. This property has important application in various fields including sensors, actuators and energy harvesting devices. The methodology for studying piezoelectricity typically involves the following steps: material selection. Identify material with piezoelectric properties that are suitable for intended application. Sample preparation. The material is prepared into a specific shape and size depending on the experiment or application. The sample may be cut, polished, or treated with chemicals to improve its property. Measurement of piezoelectric properties. There are different techniques for measuring piezoelectric properties, including the D33 method, the Berlin Court method, and the resonance method. These methods involve applying a known stress or strain to material and increase measuring the resultant electric charge or volt. Data analysis. The data obtained from the measurement is analyzed to determine the piezoelectric properties of the material, including its piezoelectric coefficient, dielectric constant, and electromechanical coupling factor. Device design and fabrication. Based on the piezoelectric properties of the material, a device can be designed and fabricated for specific application such as a pressure sensor or an energy harvester. Piezoelectric Roads materials. Piezoelectric materials are the crystals that generate electricity when compressed or vibrated. They have the unique opposite property of generating a stress when voltage is applied to them. Piezoelectric materials falls within the class of multiple solid state materials that can generate with the help of some stimulus such as heat, stress or light. Photovoltaic materials generate electricity with the application of light, or thermoelectric material generate electricity with the application of heat. Piezoelectric materials generate electricity by the application of stress. These materials are semiconductors, meaning they are much like conventional electronics generally constructed of silicon or germanium with the additional elements. Since energy demand and traffic floration motivates to dream about a device in the road would harvest the energy from the vehicles driving over it. For this, embedded piezoelectric materials beneath a road can provide the magic of converting pressure exerted by the moving vehicles into electric current. The method uses an electric generation device installed the roadbed. The electric generating device includes a plate covered with one or more protection layer lie beneath the surface of the road. In this process, materials is embedded beneath the road with the electrical generating device. For a road with embedded piezoelectric generators, part of energy the vehicle expend on road deformation is transformed into electrical energy instead of being wasted as thermal energy. This electrical generating device includes pressure plates that are covered with the protection layer or asphalt. The piezoelectric effects converts the mechanical strain into electrical energy, and the system is expected to scale up to 400 kilonewton from 1 kilometer stretch dual carriage away. Applications. Piezoelectric roads refers to use of piezoelectric materials to generate electrical energy from the mechanical stress caused by vehicles driving on the road surface. Electrical energy generated can be used to power streetlights, traffic signals, and other electronic devices. Some of the potential applications of piezoelectric rods are power generation. Piezoelectric rods can generate electricity that can be used to power streetlights, traffic signals, and other electronic devices on the roadway. This can help reduce the demand of electricity from the grid and save energy costs. Traffic monitoring. Piezoelectric sensors embedded in the road surface can detect the number and the speed of vehicles passing over the road, which can be used for traffic monitoring and management. Wireless charging. Piezoelectric rod also used to wireless charging electric vehicles which they are driving. This can help extend the range of electric vehicles and reduce the need of charging stations. Environmental monitoring. Piezoelectric sensors can be used to monitor environmental factors such as temperature, humidity, and air quality. This can provide valuable data for environmental monitoring and management. Noise reduction. Piezoelectric roads can also help reduce noise pollution caused by traffic. The energy generated by the vehicles passing over a road can be used to power noise barriers and other sound observing structures. Construction of piezoelectric roads. The first layer is laid with fine gravel and sand content. Then a thin layer of asphalt is laid which acts like a strong base of the generators. Then all the generators are wired in series to get collective output. A vitamin sheet is used to cover all the generators to provide better adhesion of concrete to asphalt. Finally, a thick layer of asphalt is laid which finishes the construction. Principle of working. The basic principle which we use to generate electricity is the piezoelectric effect. A piezoelectric material is that one which converts mechanical energy or vibration energy, thus experienced on it, to a charge which can be stored when a force or pressure is exerted on the elastic piezoelectric crystal material. The crystal gets deformed and this causes it to develop charge between them and the crystal goes back to its original state. This charge flow is converted to voltage that can be stored in a battery. We can explain about disk or shape piezoelectric buffer plate in our paper. Since the power obtained from a few of them will be in a very small amount, we use voltage amplifying circuits here. As the small and number of piezoelectric crystals increase, the energy obtained from them also increases. Street light is controlled automatically by light dependent resistors. With the help of LDRs, the street lights are automatically switched off during daytime and switched off during night time. The automatic traffic light control is made possible by two pair of IR transceivers placed on each road of four-way junction. Each transceiver pairs are kept face to face width-wise on each road. When the IR signals between each of transmitter and receiver pair gets cut proportionally according to the traffic density on each road, the traffic lights are controlled. This function with the help of program stored in microcontroller. Besides all this, charging condition of battery is sent and indicated every second to nearest traffic control room. Advantages. Piezoelectric roads have the potential to provide several advantages including energy harvesting. Piezoelectric roads generate electricity through the pressure of vehicles driving on them. This energy can be used to power nearby streetlights or traffic signals or stored in battery for future use. Reduced carbon emissions. By generating electricity from the movement of vehicles, piezoelectric roads can help reduce the carbon emissions associated with traditional power generations. Cost effective. Piezoelectric materials are relatively inexpensive to produce and once installed the maintenance cost of piezoelectric rod is relatively low. Durability. Piezoelectric materials are known for their durability and resistance to wear and tear, which means that piezoelectric rods can have long lifespan and require minimal repairs. Reduce traffic noise. The vibrations generated by driving on piezoelectric roads can be observed, resulting in reduced traffic noise and a more comfortable environment for nearby residents. Disadvantages. Limited frequency range. Piezoelectric material have a limited frequency range which can limit their use in certain applications. Temperature sensitivity. Piezoelectric material are sensitive to temperature changes which can affect their performance. Brittleness. Piezoelectric material are brittle and can be easily damaged. which can limit their use in certain applications. High cost. Some piezoelectric material can be expensive, which can make them cost prohibitive for some application. Environmental concerns. The production of some piezoelectric materials can have negative environmental impacts, including the release of hazardous chemical and waste materials. Limited strength range. Piezoelectric material have a limited strength range, which can limit their use in certain applications where large certains are required. Case study. Piezoelectric transducers are used in ultrasonic clean equipment to generate the high frequency sound waves. The transducer is made of piezoelectric material such as lead zinc titanate, which is sandwiched between two electrodes. When an electrical voltage is applied to the electrodes, the piezoelectric material deforms and produces mechanical vibrations, which are transmitted through the cleaning solution as sound waves. The frequency of sound wave is determined by the thickness of piezoelectric material and the voltage applied to the electrodes. By varying these parameters, ultrasonic cleaning equipment can be tuned to operate at specific frequencies to optimize cleaning performance. Piezoelectric transducers are preferred for ultrasonic cleaning applications because they are efficient, reliable, and can generate high power acoustic waves. Additionally, piezoelectric transducers are small, lightweight, and can be easily integrated into existing cleaning equipment. Conclusion. The above research paper and their learning creates a strike on the ideology for investigation in piezoelectricity. The necessary change or shifting is needed towards the regenerative and renewable source of energy. For the upgradation in the technical field, the authors of the respective papers have paid their complete scrutiny so as to approach effective and productive information. With the help of this research conducted, it can truly become an important energy source that won't be able to completely new to the future generations to start. Only an initial step is to be taken, which can be crucial as the depletion of fossil fuels are also a huge problem for any field. References. The author Harper Douglas has invited through online etymology dictionary. The author Godsey is invited in the year 2002, like the piezoelectric sensors, force strain, pressure, acceleration, acoustic emission sensor, material and amplifier Springer, Jacques and Pierre Curie theory. The author Sergei V. Bogdanovo invented the origin of piezoelectric effect on pyroelectric crystals. Steiner sense piezoelectric force sensors. The author Arcadia T. is invented in 1996 Fundamental of Piezoelectricity. Oxford University Press. Piezo Smart Roads International Journal of Enhanced Research has in Science, Technology and Engineering.